Hi team, welcome to Wiggins Maths. In this video we'll be focusing on integrating functions in the form f of ax plus b. In essence, functions where the input is not just a variable but an algebraic expression. As always, do not neglect the formula booklet. Now before we integrate some more complex functions, I want to take a step back to year 12 integration and put a slightly different spin on it. So here we have x squared, the integral of x squared with respect to x. I want you to think about what sort of function you would have to differentiate to get x squared. Well, it's x cubed, right? So we're going to try a slightly different approach. So if we set our function equal to x cubed, if I then differentiate that, I get 3x squared, which is not the same. But if I can make the coefficients the same, then it will have done the job for us. So now we can say the integral of x squared with respect to x was x cubed, but I needed to divide by 3 to get the same coefficient. So similarly with this one, I know it must be something to do with x to the power 4, so I'm going to let y equal x to the power 4, so that when I differentiate it, it will give me 4x cubed. Not the same coefficient, however I can deal with that. So when I integrate 3x to the power of 3 with respect to x, I know it must be to do with x to the power 4, but I want to take 3/4 of that to give me the coefficient 3 plus my constant of integration. So on to slightly more complex functions now. We can, look at something like this. I mean, I could expand it, but using our knowledge differentiation is going to be so much quicker. So I know it's going to look something like this with the power 5, right? So this time when I differentiate, I'm going to have to use my knowledge of differentiation a little bit more deeply here. So I'm going to use the chain rule, and when I use the chain rule here, I will get 15 lots of 3x subtract 2 to the power of 4. I got the 5 by putting this power down here, and a 3 from differentiating the 3x. So again, very similar, not far off what I expected, but 15 times too big. However, I now know that if I were to integrate this function with respect to x, it will be something to do with that, but now I must take 1/15 of it and add my constant of integration. Lovely, right, okay. Again, using my knowledge of exponential functions, and in particular with base e, the exponential function, I know that when I differentiate it, it will become itself or something related to itself. So I'm going to try e to the 2x add 3. So again, I'm going to have to use the chain rule. Which would give me this. It's not quite what I wanted it to be, so I'm going to make the coefficients the same. So this time it will be 1/2 of e to the 2x plus 3 plus my constant of integration. Okay, so this time I am going to be looking at something to do with cosine, right? So I'm going to let y equal to this. Again, using the chain rule. So this is going to give me a -5 sine 5x subtract 2, which is similar to what I want, but not quite perfect. So let's make it perfect. With respect to x. So I want -1/5 of cosine 5x subtract 2 plus my constant. So this is just one of the many methods that we can use to integrate slightly more complicated functions, particularly when the input is an expression rather than just a variable. Okay, again, we can look at this, and often people will panic at this point, you know, cosec squared of something. Let's just check the formula book. Well, the formula book tells me it's something to do with cot. So therefore, I'm going to try cot of 4x plus 1. And then I'm going to use the chain rule to differentiate this, which will give me -4 cosec squared 4x plus 1, which is nearly correct. So now I can say that the integral of cosec squared 4x plus 1 with respect to x is -1/4 of cot 4x plus 1 plus my constant. Okay, and then finally, slightly different looking one this time. Okay, so let's look at this and see what is it sort of going to give me. Well, it's almost like a reciprocal function, this, isn't it? So it's going to look similar to this, using my knowledge of 1 over x. So when I differentiate this time, I will get, using the chain rule, 5 over 5x plus 1, which is nearly correct. So I just need to make the coefficients the same. So I need to take 2/5 of ln 5x plus 1 plus my constant. Lovely stuff. Okay, so that's it for this video. Remember, watching the video does not instantly mean you will get it. Practice is the most important thing, and the more you practice, the better you will become. If you found this video useful, please subscribe, tell your peers. I'll be aiming to upload a few videos each week to ensure that we are as successful as possible. And of course, remember, amateurs call it genius, masters call it practice.